Good evening. Welcome to the National Building Museum. It's a little more intimate crowd than we were anticipating, thanks to the storm. My name is Scott Kratz. I'm the Vice President for Education here at the National Building Museum. And tonight we present a program entitled Inspired by Nature as part of our series For the Greener Good, Conversations That Will Change the World. In her groundbreaking book, The Biomimicry, Janine Benyus describes how nature manufactures materials. One of nature's tricks is to create using what she describes as life-friendly conditions. She says, in water, at room temperature, without harsh chemicals or high pressure. Contrast this with the way we currently make most of our building materials. We form metals under incredible pressure. We melt and shape glass and ceramics under intense heat. And when manufacturing plastics, we often leave a residue of pollutants that need to be carefully disposed of. Again, as she tells us, consider that the abalone shell is twice as tough as any ceramic we know. Spider silk is 5 times stronger than steel, and muscle adhesive works underwater and sticks to anything even without a primer. What can we learn from nature? How can we be inspired by nature to use less energy, to leave a smaller footprint, and to create more resilient products to make a greener, stronger, and more sustainable world? And beyond just products, what if nature can inspire our designs and our construction processes? Would that save us money, energy, and resources? That's the topic for our discussion this evening. We've assembled a very impressive panel, all 4 of which came from out of town. Very impressive, given our snow. And I look forward to an in-depth and fascinating talk. One quick program note, on February 17th, the For the Greener Good series continues with a discussion entitled Life After Plastic. Many believe as the price of oil rises, the cost of plastic building materials become increasingly cost prohibitive. What is the future of alternative products for the construction industry? Panelists will include product manufacturers, designers, and a representative from the American Chemical Society. It should be a great program. And I would like to share with everyone tonight that we are tweeting tonight. It's our first time we've live tweeted. So if anybody is out there tweeting, the hashtag is #FGG. We encourage you to chime in on the conversation and ask a question. We could not do these programs without our funder. The For the Greener Good series is presented by the museum's sustainability partner, the Home Depot Foundation, and we'd like to thank them for the generous support of this innovative lecture series. And programs such as tonight have been designed to incorporate your questions and thoughts. They're meant to be conversational in format. So we're going to break periodically and take some Q&A from the audience. Before we begin, can we just get a quick idea of who is in the audience? It'll help the panelists have an idea of who they're speaking to. Raise your hand if there's architects in the audience. Great. Planners? Excellent. Landscape architects? Great. Engineers? Students? Great, we've got some students out. Federal or state employees? Educators? Excellent, great. Let me give a quick introduction to everyone and we're gonna go ahead and get started. Each of them will give a brief presentation and then we'll get to the discussion. Taryn Mead is the biologist at the design table for the Biomimicry Guild. Her training in ecology and the socio-industrial aspects of environmental issues provides a systems-based platform for discussion of biomimetic principles and methodologies. At the Guild, she specializes in nature's function at the ecosystem level. With a bird's eye view on planning, architectural, and production challenges, she provides insights into ecological principles that can be used to enhance the way design fits into the landscape of a place. She guides clients through a design process that asks the local organisms how to flourish in the regional habitat condition and incorporate ecosystem nutrient cycling into landscape scale designs. She participated in the National Student Exchange Program and worked at the Lyle Center for the Regenerative Studies at Cal Poly Pomona. She graduated cum laude with degrees in environmental studies and biology with an emphasis in ecology from Western State College of Colorado. She moved to Helena, Montana, where she joined the Guild after working as a biologist on commercial fishing vessels in the Bering Sea. Chris Garvin serves as a project lead for many of Terrapin's consulting engagements while also managing projects for Cook Fox Architects, where he's a senior associate. His interests include high-performance design at both the building and community scale, zero-energy communities, biomimicry, and water conservation. An integral contributor to Terrapin's development, he was named a partner in 2008. Complementing his work at Terrapin, he lectures frequently on sustainable design and is taught at the Pratt Institute's Center for Professional Practice since 2002. He's currently developing an exhibition that I'd love to hear more about on biomimicry and the built environment, lessons learned from nature. He received a Bachelor of Architecture degrees with honors from Carnegie Mellon University, where he worked with a noted professor, and I should add past For the Greater Good speaker, Vivian Lofness, and spent a year at the École Polytechnique Fédérale in Lausanne, Switzerland. He became a licensed architect in '98 and maintains professional licenses in New York, New Jersey, Illinois, and North Carolina. Veit Kugel is a senior associate at KVA Maddox. He graduated with a Master of Architecture and Urban Design degree from the University of Stuttgart in Germany. He received a scholarship by the German Academic Exchange Service in 1995 to attend a master's degree program in architecture at the Southern California Institute of Architect, or SCI-Arc, in Los Angeles, where he graduated in 1997. After practicing in Stuttgart and Los Angeles, he joined Kennedy and Voilich Architecture in 1999. He was involved as a teaching assistant for Professor Sheila Kennedy at the Graduate School of Design at Harvard University and co-authored the book Bugs, Fish, Floors and Ceiling, Luminous Bodies and the Contemporary Problem of Material Presence. Since the fall of 2000, he has led teams of designers and consulting engineers for architectural competitions, exhibitions, and projects varying in scale from building products to large-scale infrastructure projects in the private and public sector. Our moderator this evening will be Susan Snassi, editor-in-chief of Metropolis magazine and a frequent speaker at the museum, who's moderated several of our For the Greener Good programs. The Metropolis is the award-winning New York City-based magazine of architecture and design. Since 1986, she has led the magazine in landmark design journalism, achieving domestic and international recognition. She's internationally recognized as an authority on sustainability and design. She sits on boards of the Council for Interior Design Accreditation, the Center for Architecture Advisory Board, and the Landscape Architecture Foundation. She's been honored with two IDA presidential commendations, is an honorary member of ASLA and AIA in New York City, and the 2008 recipient of the ASID's Patrons Prize and Presidential Commendation. She holds an MA in Modern European History from Rutgers University and honorary doctorates from Kendall College of Art and Design and the Art Center College of Design and the Pacific Northwest College of Art. Each of the panelists are going to give quick 5-minute presentations to begin the conversation, and the order will be Taryn, Chris, and then Veit. So, Taryn?
I don't know if anyone's ever tried to give a 5-minute presentation about something you really love, but it's very, very hard. So I will do my best to be succinct. Everyone knows that we have environmental problems, right? We all know global warming, loss of the rainforest, blah, 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 blah. I refer to myself as a recovering activist sometimes, actually, because I used to talk a lot about problems, but got pretty burnt out and decided to do something else. Hence, I'm a biologist at the design table now for the Biomimicry Guild. I was a field biologist for a long time, and now I spend my time mostly translating biology for all of you, non-biologists. And so at the Biomimicry Guild, we view environmental problems in terms of it being our level of adaptedness to the planet. So all of the other organisms who live here on the planet know how to live here sustainably, and there's a particular way that they fit in. But our strategy then for approaching environmental problems is to look more at how we can be more well adapted to the conditions of the planet. And so I know this is a controversial statement to make, but I would beg that humans actually are nature. And I think that everything that we do is natural. I think that not everything we do is well adapted. And so the key to really learning how to be more sustainable is to learn what it means to be well adapted to the environmental conditions here. Like all the other organisms on the planet are subject to the same conditions of the climate that's changing around us all the time, all of the abiotic factors, nutrient flows, these sorts of things. And so if we can understand how all these other organisms are fitting in these same conditions, we can start to really answer some questions for ourselves. So biomimicry is a new way of viewing the natural world based not on what we can extract from it, but rather what we can learn from it. So it's viewing nature as model, measure, and mentor. And when you take this basic principle, as most of you probably know, biomimicry can be applied to a lot of different disciplines. My area of emphasis tends to be in the built environment because I'm an ecologist. We have some material scientists on staff who focus on product design, and they work with material scientists. We have some chemists on staff who focus on green chemistry techniques, but my specialization within the built environment is to kind of take it up to scale. So when we say model, measure, and mentor, if we take the idea of applying function as sort of looking to nature as a model. So we're looking at how a bromeliad, for instance, is capturing water and the shape that it's using to capture water, and applying that shape then to some sort of building or some sort of construction. So it's kind of looking at the form, but form following function. So it's not biomorphic necessarily. Biomorphic is part of it in some instances, but you're looking specifically at the function of something. The next application within the built environment is at the principle level. So you might think of biomimicry being applied, taking one specific organismal strategy and applying that organismal strategy. But if we're looking at the principle level, we're kind of taking it up to nature as a mentor. So all of the organisms surviving within these conditions abide by the same sort of set of laws, which I'll go into in just a second. And they exemplify the set of principles that that sort of describe how they respond to these conditions. And so if we apply these principles, we can also get more towards what it means to be well adapted. And then finally, we can view nature as measure. And this is looking at how specific organisms perform and establishing our performance criteria for products or materials to be that of the way an organism would design that same material. So it kind of takes us away from sort of this arbitrary, what is sustainability and how are we going to get there, to these very specific parameters that are biologically testable. And the premise then for how we're gauging our success is also testable. So as I mentioned, here's a concept map that we use to describe how life does what it does. These are life's principles. Life optimizes rather than maximizes. As you can see, there are about 26 or so, but for the purposes of working with groups, I tend to kind of hone in on the ones that we think are the most important. So life optimizes rather than maximizes. Basically what that means is sort of the Goldilocks principle. It's not too big, it's not too small, it's just the right size, right? Life leverages interdependence. So it recognizes that there are relationships around it all over the place, and it makes the most of those relationships. Life uses benign manufacturing, so it causes no harm in the production. It actually creates conditions conducive to life when it produces some sort of material. Life is resilient, so it can respond in the midst of disturbance. Integrates cyclic processes, so it's always responding to those conditions around it which are moving in circles. And finally, life is locally attuned and responsive. So we've been doing some work with HOK, who is one of our largest clients, applying life's principles to the city scale and city planning. Imagine what it's like to create a design code for a city based on the design code of life. So that's effectively kind of what we're trying to do in our prototyping work with them. We've also been working a lot on developing a concept called ecological performance standards. And so this comes back to the idea of nature as measure. And if you look at this forest system here, any given ecosystem, there are specific rates of cycling that happen within that system. So for instance, there are rates of water filtration. There are rates of evapotranspiration, right? So how much water is being processed by the plants in any given ecosystem. And there are rates of nitrogen and phosphorus cycling. In the majority of, I shouldn't say in the majority, in some of the ecosystems that humans live in, there's a complete data set about the rates of water filtration and exactly how pure that water is when it comes through that ecosystem. And there's data out there about how the trees are evapotranspirating, how much water they're pulling out of the soil and releasing into the air at any given moment. And so by pulling this biological research out, we can start applying it to the built environment in a way that's very meaningful. So for instance, if you took the evapotranspiration rate and put a building as a surrogate for a tree in this forest ecosystem, for instance, You can imagine that then the rooftop surface, if it's a green roof, we can put a green roof there, we should have an expectation that that rooftop is going to release the same amount of water that a tree would in that environment. So one particular project we're working on in India right now, I believe that something like 10% of the rainfall that falls in that forest is again released back into the air. And this evapotranspiration rate is really important because it drives the macroclimatic patterns and drives the monsoon season there. So when we build in this environment, then we also need our buildings to evapotranspirate 10% of the water that falls. So this is one way that we've been applying this sort of nature as measure idea. Lots of work to be done there. So from our perspective, if you take all the metrics that we're collecting, it all comes down to the fact that humans, in our view, and from the biomimicry perspective, humans will be truly sustainable when our cities, in this image here, are functionally indistinguishable from our forests. That's all for me. Thanks.
Just want to thank everyone for coming on this terrible weather day. It's great to have people to talk to. It could have been just the five of us in that camera for a little while. So it's nice to see some faces in the audience. So at Terrapin, we focus on working with our clients around biophilia and biomimicry. And I'm just going to take a second to talk about the distinction between those two things. Well, actually, Taryn's done a great job on biomimicry, so I'm going to skip that. But biophilia is really looking at how the human affinity for nature and for life and the positive impacts on our health and productivity that connecting to nature has on the human species for trying to keep it as broad as possible. And there's actually a growing body of work that looks at stress level reduction, improved health outcomes around connecting to nature that we work to integrate into our architectural and design work with our clients and at Cook Plus Fox Architects. So I'm gonna go through just a couple projects that we've been working on over the last couple years. This is the image in the center is a proposal for a high-rise in a new city in the Middle East, sort of looking at a couple different ideas around the termite mound. One, looking at sort of this atrium, series of atrium spaces that actually allows you to pre-cool passively the air and also to filter the air before it enters the building. And then also this idea of creating a form that's self-shading in a very hot, intense environment. This is an interior looking at a double wall system that not only has these sort of environmental control aspects of reducing the exterior temperature versus the interior temperature and some thermal cycling at the different levels of the building, but also integrating this garden at the exterior edge so that people sort of elevated above the ground and isolated in tall buildings have an intimate connection back to nature in those spaces. And they're looking at daylighting to reduce energy consumption, but also to reset the eye's stress level and fatigue that we know it happens with artificial lighting. So really thinking about sort of how our bodies have evolved with nature. And I would actually agree with Taryn's proposition that we are nature. And so we have to sort of find that how we are tuned in back into it. This same project, we were actually looking at connecting all the cyclical flows of water and waste and nutrients in the industrial complex of different industries that were being built, but also the city's actual flows of waste and water cycling as well, to create sort of an organism of a city that would be adapted to the fairly harsh environment that it was situated in on the Red Sea. And this is coming off of a lot of work around industrial ecosystems being done at Yale, but also there are 20 years of experience here in Kronborg, Denmark, looking at interconnecting different industries to take the concept of waste and eliminate that concept. And if you look at nature, there is no waste in nature. There's always some organism that uses what is left over from something else for another value. Everything has a value in nature. And so, we say we have these waste products from our industrial production. Well, here in this project, they've taken those wastes and actually found industries that use it as a feedstock to create another product that's valuable for for our civilization. And then sort of going to the complete opposite scale. This is the interior of a house in Syracuse, New York, called Live Work Home that Cook Plus Fox designed with Terrapin. We won a competition. This is a affordable housing project in Syracuse to redevelop a pretty sort of rundown neighborhood in the city. And we looked at when we were looking at the lighting and this idea of daylight and the sort of positive values of biophilia, connecting back to biophilia, we also were inspired by sort of the dappled light of the forest. And so we created a series of skylights and these screen partitions that would filter light and actually sort of open and close the spaces to respond to the needs of the inhabitants and also respond to the climate outdoors. So in the spring and summer, the house opens up and sort of engages in sort of the life of the rebirth of the landscape around it. And then in the winter, it can close down and sort of bunker down and hibernate for the winter with the rest of nature around it. And then this last project is even at a larger scale. We're partnering with the Biomimicry Guild on a project, multi-year collaboration with NYSERDA, which is the New York State Energy and Research Development Authority. And their aim here is to introduce biomimicry to manufacturers in New York State and to create new products and new processes that will be more attuned to natural processes and give manufacturers in New York State economic benefit and marketing advantage in an ever-increasing competitive world. So it's a new project. It just started in December of last year, and we're going to have our first major charrette with a battery consortium in April. And so we're looking forward to sort of how we can take these life's principles and engage in a wide series and sort of expand the work that the Guild's been doing for years now in New York State. So, thank you.
Okay, I think we're going to have an enormous jump in scale here. Working for Kennedy in Village Architecture. Can you hear me? Oh, that's better. We are a small architecture firm, not too small, but and we also are KVA Maddox, and we have a portion that is a material research group in our firm. And so we specialize in working with large manufacturers like GE or North Face or any of those to come up for new product applications, materials applications, and so on. So I want to start with, and I'm really in the trenches of day-to-day work of architecture, so it's probably a little less theoretical. We're going to start with a project that's people off the grid portable light project that we have, that is a product that is a biomimicry product in a way, because it harvests energy, it stores energy, and then it emits light and power. And it is used globally with NGOs for all the people in the world that are off the grid. And off the grid and having no electricity really means, in many ways, being not part of the first world, because one has to understand that with the advent of the industrial revolution and the electrifying the country, really we increased our working day to 24 hours. We increased our safety. It's a huge, huge change in society, which really all our wealth is based on. So bringing this to people that don't have that is really an incredible thing. So it's just a small thing. It comes as a kit. It can be integrated locally in Mexico, for instance. It can be woven by the local ritual communities into their bags. It allows them to communicate. It allows them to produce longer and actually keep their life, because otherwise big in the energy grid and power lines will come in, with them come streets, with them come the rest of our society, which we all know what happens to indigenous communities. This is a product, and I'm just focusing on projects that are just currently going on. This is in Haiti. This is traveling midwives. They use the bag that we provide to them to basically have light, have power for their small instruments, and also to charge their cell phones, which sounds like not as important, but in South Africa, where we have a similar project, this is very important because the whole communication of the medical field is built on SMS. So if your battery in your cell phone is down, you're out of communication with the rest of your field. And this is actually an NGO founded by the Clinton Initiative, Global Initiative, that are park rangers. They protect beaches where turtles breed, and we developed a slightly different bag for them that they can actually locally produce. And it switches the LED lights to a red light, because Taryn, you would probably know better why turtles love red lights and hate white light. But so we're learning, and it's wonderful, this project. So that's one part. Then I'm getting into the next scale, and that's power tracking the sun. We currently are getting a permit for we were invited to a competition for the International Building Exhibition in Hamburg, Germany, which occurs in not set intervals since 1911. And it's quite a big show where new themes are applied to either urbanism or architecture and tested there. So we're in the field of smart material houses with 3 others, and I'm gonna just talk about one aspect of the building, which is the outer membrane that has PV cells on them and is basically a shading. It controls the shading, it controls the solar exposure, it harvests energy, it controls the privacy from the inside, so it transforms, and this is like a crude animation of what can happen. Oops. It can unfold, rotate, and so on to kind of adapt to either the climate or the user's wishes from the inside. And what's really interesting to us as architects is not necessarily how it can mimicry maybe an adaptation or a leaf or so, but what would it do to architecture? How will spaces be transformed like that? How can it create a new architecture and a new architectural expression? And here you can see the front portion of this facade has strips. They're of a membrane. There are thin film PV cells applicated to it, and those rotate and track the sun. And you see how the facade changes. And at the same time, the facade can be controlled from the inside. So if you want more privacy, you basically close it. If you want less privacy, because this is in a more European dense setting, you can open it. If you need more light, the backside of those fins or membrane strips are highly reflective, so you can actually bring more light in if you just turn it the other way, and you can decide, I don't care about my power harvesting. But it also does a lot of things to your experience as the user. It's a carbon negative building because it's entirely built out of what's called a Brettstapel construction, which is basically a giant butcher block without glue, just doweled. So it is entirely recyclable, and the rest is less carbon negative, but it offsets basically everything. So that's quite interesting. And that really replaces the typical concrete slab construction and concrete even wall construction in Europe. And it can be, what's very nice, socially nice, is that this can be actually built, the elements can be built by very small companies. You don't need to be a huge national corporation. The third and the last, and then I'm done, is a competition we did for the Expo 2000, and actually that's a typo, 12 in Jeju, Korea. And it's a reuse of an existing silo as a hotel and maritime exhibition center. And with all our projects, we're trying to connect to a larger setting, a larger network. Like one's is a social network. The second example was more connecting to earth and wind and sun and the environment like that, and including, as Terrence says, as we are nature too, the people inside our houses. They are part of that. So, and this one tries to just connect to the ocean in front of it. And we're using, I don't know if everybody's familiar with the Argo system that exists out there that has about approximately 3,000 buoys that are submerged and collect data in the ocean worldwide, and then they pop up, they transmit their data, and then this data is actually open to the public, so it's not a privately owned or hold data. And it's interesting to understand that I just read 78% of our planet is covered by water, and it's really the part of the planet, the part of the space we know the least about. I think we know sometimes more about things that are outside of our planet than about the ocean. So the project is really very, very simple. It's a competition, so it's it's a reuse of an existing silo, and the upper portion, and it's covered with a mesh, and the upper portion will be basically a huge monitor that translates data and visualize data that is collected from the bay, from the buoys in this bay and outside the bay, about water movement and salt content and what happens beneath the surface of the ocean. So, because we really have a tendency to look at fish in the surface, but there is this huge body, it moves. And then the lower portion, the same mesh, water will be pumped up and percolates down, aerates, cleaned, and go back into the bay. And what does it do for the building? It will cool the building, it will shield the building. So we're trying to, just with the one element that this is also about, the maritime environment, to create a connection. So, and I just put that in for fun, because this is how Sheila and I, way back 10 years, started to really dive into this when we looked at bioluminescence, and found this in one of very old lectures. We all shine on. In a way, what we really are about is there is this wider settings that are maybe ecosystems or man-made arcosystems or whatever systems, and try to fit in, try to understand what's interesting, and then come up with something that can be applied to a product or a building and urban design as well. So, and we hope we all shine on.
Why not? Okay, so I have the one first question that I didn't even plan to ask, but since all of you kind of talked about the fact that we are nature, and we spent the last century saying that we weren't. I mean, we really tried to get away from nature as much as possible, and modern architecture basically paid lip service to nature, using it as wallpaper, but really not relating to it at all. I mean, you know, the Farnsworth house is a perfect example. It's beautiful, it's in nature, it's part of nature, it's closed off from nature through the wall, through the glass wall. So how do we begin to understand this profound connection of our bodies, our minds, ourselves, our systems to nature, and begin to understand this as designers, as human beings, as biologists, as anybody inhabiting this earth? What's the beginning of this? But who has, like, I'd like to get just one bit of wisdom. Chris.
I think we have to go back into nature. I mean, I think, you know, if you read about nature deficit disorder with children these days and the detrimental effects, I think, you know, with technology and the pace of life, increasing every day. We've just stepped out of nature and put ourselves indoors for too long, and we've lost that connection. And I think when you go to a national park or you go into the woods in your backyard and you sort of just slow down enough to look away from your BlackBerry and actually look around, it's kind of, I was actually coming down the train today, and I have a whole bunch of work in my bag that I'm supposed to be doing, and I'd spent most of the time just looking out the window and looking at the snow on the trees. It was just gorgeous. There was just no way around it. You have to admit that.
Yeah, so I think that's lovely. But I think the kids today are on their iPads, iPhones, and looking into this blue light, which is one spectrum of the light that we all need to survive, to live a natural life. So we really don't have a world that really pays attention to nature. So let's ask Taryn, the biologist who is more intimately connected to the natural world.
I don't know about that. Everybody has their own way of connecting.
Well, but it's a really interesting thing because you see the processes of the natural world, you experiment, you look at them, you understand them. You, by your profession, have to throw yourself into the natural world. You can't spend all your time researching things in a laboratory. You really have to get your hands dirty and dig around and catch that little animal or whatever you're studying.
Right.
So what is your wisdom on this, and how does the Biomimicry Guild talk about these issues? I know you guys go to the jungles and take people with you and have this immersive experience in nature and the really great stuff happening, but that's like 200 people in 2 years. So, and we are millions of people clueless.
Right.
So,
I was thinking a lot about this question today, actually, and I started thinking about sort of the history of germ theory. So bear with me, and I'll get back to the point in a second. So germ theory, as we know it today in its modern indoctrination, that germs give us disease. This was first actually only realized and widely accepted in 1870. So that means that it's been 140 years that we've thought that germs equals dirt equals unhealthy. And I think that we need to, and so consequently we've been going further and further down this path of hygiene, right? We're sanitizing everything all the time and sanitizing our hands, and other people are dirty and everything's like gonna make you sick. But I think that we need to, and consequently we've had the same experience in the built environment. We want to keep the dirt out and the life out there because that's dirty and that's where the germs are and that's where the stuff is that makes you sick. And then all the things inside our spaces are clean and proper and hygienic. But I think we need to dissociate this idea that health is hygiene because they are different concepts. And I think bringing the natural world back into our lives in a way that we understand how the difference between those things will go a long way in a lot of different disciplines, not just in the built environment, but in healthcare and our social systems, going back to this idea of nature deficit disorder.
So every household, every office has a huge bottle of Purell, and you see these little kids playing together, and the teacher will have a bottle of Purell because the kids have to touch each other. These are 5-year-olds. And the Purell is there to sanitize them after they touch each other. So I think there's like some fundamental thing that has to happen for us to reconnect. Because have we reached a tipping point where we can't reconnect anymore? I don't want to be pessimistic about that.
Right, no, I understand absolutely. I think we're going to come to a point where our biological systems won't work anymore. And we're just going to have to reconnect. We won't really have much of a choice. And I'm not doomsdayer by any means. I'm hopeful, or I wouldn't be here. I'd still be in the Bering Sea counting fish. But I think that we'll just get to a point eventually where we're understanding the biological world enough. So the amount of information that we understand about the biological world is doubling every 5 years. That's an immense amount of knowledge that we're constantly gaining. And as that becomes more of our cultural vernacular about how we talk about things, I think that awareness will grow.
Well, I think the really good signs is that a humongous multinational firm like HOK is standardizing a biomimicry, and they're working with you. So there's, those enormous developments that they're working with begin to show some of that understanding, and I think reconnecting is happening. So I think as more and more of that happens, that's where I see the hopeful signs. And I think with Feet's beautiful work on bioluminescence and the work that is can be locally manufactured, locally used, it's non-grid dependent. That to me is actually a really great lesson for the developed world.
Oh yeah, I
Yeah.
mean we kind of struggling with the and we hoping that like we get a call maybe tomorrow.
Yeah.
Somebody watches this from from a big manufacturer, because this could be, this works more and more in our world too. This is not only for the third world or the second world, or if those categories even apply, but I guess that's accepted. I think what really happened with Farnworth, like modernism, is we were thinking we were trying to create everything as a singular event. So we were in architecture making singular-use spaces. We were making singular-use materials that would do one thing good, and reading through, the biomimicry book again after years, and reconnecting to that. And it's really about that there is, our world is multifaceted, and there will be a breaking point where we cannot extract ourselves mentally or with hygiene. I mean, hygiene, it's really one period where all those things occur. Electricity, hygiene, all those things, the origin of modern architecture, modern urbanism, where everything had to be separated. Broad cities, like you live here, you work there. I mean, because architecture is always very crude and primitive in a way, it spelled it out. And I think and I may be super optimistic about things, but I see a lot of beauty, if you really study this. And then, to me, it's not only that it functions that and that we save the world, but that it's a joy that it creates something beautiful, like the space we are in. I mean, this is why I became an architect. And so
But
I think I'm very hopeful that we will just overcome that. The new generations, and if I see those kids, they don't even have the idea that things are, singular functions in spaces, and that's how, residential work will change that. And we all multitasking. I mean, this word was probably not really known as like 20 or 30 years ago. I mean, it was known. We always do this, but we never acknowledged it. So we're starting acknowledging that we are a multitasking part of nature. And so as this becomes more and more common sense in the way we operate and the way we do things, I'm very hopeful.
See, I think it's really interesting. When I heard the term World Wide Web, I began to understand the connections, and not just the way it was thought of, not just information flow, but really understanding that it is a web of connections that we have to think about, and it's not these distinct sort of freelancers in every corner, but there are these connected people and connected sort of pieces of knowledge that complement each other. So I think
and it really is, for instance, in architecture, it's like, and hygiene, everything is a very linear thinking.
Right.
It's like there's a beginning point and an end point, and everything that's on the side we ignore because we can't deal with that. Well, now that we have more computational powers and all that, we can actually do a lot more complex things. And that will really help us, and that will bring us back to nature, even though it's the most unnatural way, and will definitely not satisfy your the fear of not being in touch with the actual natural well, I don't know what the natural environment is. We discussed that, because to me,
Yeah.
it's not such a distinction, or it's like either a romantic term, or it's man versus nature, or we all are nature, which we agree on. So it's like, this is nature here. It's man-made nature. If I'm in a termite hill, I'm in something that's termite-made nature, you know, and I have to deal with all the shortfalls, if there are any, I don't know.
I would just add that at the same time that we're learning so much about nature and about these biological systems and understanding about climate change and all this information we're learning that's sometimes mind-boggling, at the same time we're also seeing some of the sort of basic principles of urban design and architecture really not working any longer, or not working for our current and sort of projected society. So infrastructure systems that were built 100 years ago just do not function, and were built for, you know, a certain function, and, you know, combined sewer systems were really designed that way because we had horses on the streets. So there was manure that needed to go down into that sewer and get off the street for a hygiene reason. Well, we don't have that any longer, so we don't need combined sewers. And, you know, that thinking of what worked 100 years ago isn't necessarily what works now, and we know so much more that we can't ignore that knowledge, I think. And I think it's very hard to hide the intelligence of nature once you understand it. It just keeps coming back, and you keep meeting more people who have a similar idea and maybe developing in a different design sense, but they're all connected because people are just being inspired and trying to solve these problems, these very basic problems that all humans have.
So, you know, this is really interesting because nature contains extreme beauty and extreme homeliness. And the architecture world right now that tries to be inspired by nature is pretty much on the extreme homeliness side. So how does it get to produce the peacock instead of the guppy? I mean, I really, is it because we don't have a deep understanding of this thing yet? Because I keep thinking that when we first started talking about this some years ago, that we would be seeing amazing buildings that understood their climate condition, that understood the sort of, not the superficial local cultural gewgaws and the ethnic kind of patterns, but really understood where it was, what it did in that climate, what kind of people were its users. So it reflected that. And we have the same glass box everywhere. Now it's much more efficient. We have amazing energy numbers that come out of some of these great LEED Platinum buildings, like the Bank of America building. I mean, there's just fantastic technology again, but we're still removed. So, and we're still not that sort of spectacularly beautiful thing that nature produces. So how does architecture, especially architecture, but design, product design at every scale, begins to look beautiful again? Architects. I want the architect.
To speak to that, yes. I think it is what you're talking about, the phenomenon that we're just trying to make things more energy efficient, that we know that come out of modernism or industrialization, which I like better than, because modernism is an architecture period. And to overcome that, we will definitely not develop, we will not get smarter with our buildings, all those things. And I agree with that. It's interesting because I'm working back. You know, you can get the boy out of country, but a country out of the boy, and I have to work back in Germany of all places, which is interesting, and because I come from there. And seeing, for instance, energy efficiency there, the code required, 30 years ago it was 300 watts per square meter. The code requires currently that you are at around 100 watts per square meters, and when you look at how much, and it will 2012 require that you're about 80 watt per square meters. And so the energy consumption of those buildings will get reduced and reduced, but they also get at a point where you can achieve this with insulation, which is kind of the way of bigger is better. You know, my car gets heavier, I put a bigger engine in there. We hit the same thing as the car industry hit like 30 years ago, and we have hybrid cars. we need hybrid architecture. I think at the core of that are two things that bring me back to nature, which have nothing to do necessarily with nature. One is that it's the singularity that is in a central system that's inherent in our buildings, inherent in our, like the sewer system. It has a central command. Nothing in nature works like that. It's usually the power of many, and the collaboration of them, rather than a singular system that everybody taps in and every bacteria gives their part of what they're not waste, but whatever they need to get rid of, into like the system, and then it goes to something else. It does not work like that. So, and if we do that, if we understand that, then we're not going to replicate like the same old box. Like I'm really looking forward to make this membrane that changes the outer form and the inner experience of that building that we're doing there. I'm at the same time incredibly fearful of what it really produced, because I think I can't compute what it really means, because this is where the architectural expression moves forward to something else. And underneath it, there's quite a box, because that appears to be the cheapest thing we can build underneath it currently.
And I think that comes out of sort of traditions of construction that we are, that are very slow to change and very ingrained in certain industries and cost effectiveness and liability, all these issues around real estate. So we have this sort of very slowly advancing, industry where, cell phones on a job site are like magical devices today. You'd think that's crazy, but they still are that's a new thing on a construction site. And at the same time, we have sort of a lot of material research coming from a completely different direction that are transforming materials in different industries. And I think that sort of level, like nanotechnology in particular at a biomimetic level, has a potential to really transform materials that give us more tools to actually make our buildings vastly different and address things in a different way. But I think the industries have yet to sort of really hit that tipping point where there's a truly new palette. You get sort of these right now there's this experimentation stage that we're seeing where we're making sort of crude models of what we think could be a future, and using today's materials that don't quite work, and they may not actually function they may fail over a short period of time. But it's a learning process where we're trying to get to something new and we don't really know what it is. I think it's just it's an unfortunate fact that it takes time to learn a new thing. And in a society where we want everything to be, online and accessible and immediate gratification, people get frustrated and tend to ignore those things that actually we need to have that patience to really learn from nature and really engage in that long innovation process, which is unfortunate. It's a long process. It takes years to innovate a new material or a new process into an actual commercial product.
So now we have some things in place already. So you mentioned NYSERDA, which stands for what?
New York Energy Research Development Authority.
So New York State.
Yes.
Yes. Okay. And then there's a Center for Excellence which researches building products in Syracuse, which is also a New York State institution that was established by a Republican governor, Governor Pataki.
Yes.
Pretty cool stuff. So what I'd like to kind of say now or ask you about, you're beginning to charrette on batteries and developing those. But I think what Kennedy Voilek does in terms of materials, I mean, if I were NYSERDA and if I were the Center for Excellence, I'd be like hunting them down because they're ready to make this stuff into product. And New York State wants to establish manufacturing of green products. So how do we sort of push this along faster? Because there is a lot of that kind of knowledge that Kennedy Voilek has, and it's out there. It's just, the institutions, I mean, I think it's great that you're doing the batteries, but I wish that they were also doing something about those materials that they're innovating.
Well, maybe that's
I'm
the
very
call that
grateful
fight
you do
is
the batteries because I need those batteries 2013. I can tell you exactly April 1st. No. I mean, I think I see Chris's point because being in that, and I salute you for that work you're doing because architecture is, everybody thinks architecture is like the materials that put together and you have a structure and then we can occupy it. Architecture, the longer you practice, the more you understand is a legal framework, and there's just the brick and mortar is just really the last piece that comes to it. And with innovative materials and all of that, it's legal, I mean, legal framework, you know. We, for instance, we work on this experimental prototypal stage. We have to declare parts of our building as an art installation. But you can only do it that far if, for instance, electricity is involved, you know, and things like this. So I think it's time. Yeah, architecture is just like really always the last thing on the bandwagon, and it moves very slowly compared to mass production. It's also not a mass production process. It's not an industrialized process. We're building by hands with machines. We're not mass producing our buildings, not a single one. And we have tried for 50 years to mass produce buildings, and we haven't. It's still man-made. So that's I think where the disconnect is, and that's where like we're so used to like getting things instantly and things changing, like the cell phones of 5 years ago. They look, well, I don't even want to use it.
There is architecture has a really good friend in art, and art has a really good friend in technology and in materials. So how do these two, which are natural collaborators, art and architecture have always been, the best art and architecture have always been together. And so, you know, whether it was plop art in the 60s and 70s, or really art being part of buildings, or amazing things like people like Sheila Hicks, who kind of used her amazing weavings to liven up the dead modern buildings, the lobbies, because they were so empty. So, but there's this sort of, I mean, I could see a bioluminescent thing in one of your buildings that would call attention to a technology and a kind of a beautiful artwork that actually provoked people to think, oh my goodness, what is this? And then it becomes like part of the questioning of you know, of a material, of an idea, of a way of light is delivered. So I mean, it just brings so much together, and I'm just wondering are you guys doing any of that in your work, that kind of tech art that really helps people into this next level?
We're trying, yes.
If you don't, you should do it.
Well, we're trying. It's like we just did in Philadelphia, we did a installation that's called Virtual Companion, which is an architectural wall treatment of a very narrow corridor that on the natural but not on the planned path of getting to the main campus is the natural way to get in there. So therefore it's like really occupied and busy. And in order to expand it, we did an installation with LED lights that creates a virtual companion, basically expanding like a mirror. Yeah, but we didn't want to use a mirror, and that's like a virtual companion. When you go in there, there's a glass wall that has LEDs behind it, and you will a companion will get selected, and it walks up with you, expanding the space to the side. And actually, I'm really happy because it works. It's like less claustrophobic because we put more people in it that really exist in a space that doesn't exist.
So are the LEDs powered by the sun?
The LEDs could be powered by the sun. That depends on if they just take that portion of the power that gets delivered to this building.
Exactly, because those are fairly easy to do.
But I mean, to me, there is like the systems, and then, and you saw that on the project, in particular the project in Hamburg, where we're trying to come up with new architectural expression that just follows that. I mean, if you have in front of your facade a thing that just like changes and turns and does and reflects light in, and you can manipulate it if you want it differently, or otherwise it will just follow naturally the sun and do all that, that will change the way we feel about it. That will also any moment you will learn where the sun probably is, or if there is no sun, just by knowing that, oh, they're turned like this, it must be 4 o'clock. It's almost like a watch, you know. It has many levels, and it goes into an art or architectural sphere. I mean, I agree, I'm very frustrated with just a better insulation material that doesn't show.
Yeah, yeah.
'Cause-
So Scott is standing, so that means that we need the audience to get involved. So, any hands up? Yes.
Hi, this is
Yeah, it's on.
on.
Yep,
You can hear me?
okay.
Okay. The 19th century has popped up in some of what you're talking about, Industrial Revolution, the city of the 19th century. And I want to go back to that period at the end of the 19th century when modernism wasn't quite so monolithic and wasn't all glass boxes. And certainly the writing of the Transcendentalists, the work in Art Nouveau, the arts and crafts movement in the UK, and Louis Sullivan in particular, I think in the US, left or sort of showed us a path of a modernism that was both biomimetic and biophilic. And I'm just curious if you guys want to talk at all about Sullivan, right, or that path not taken of the sort of biomodernism.
Well, can I answer that one?
Definitely.
I'm sure you would rather hear from the architects and stuff. I'm just on the sidelines here. But I really feel that Art Nouveau and Sullivan's patterning are really beautiful understanding of nature's forms, but not of nature's processes. And I think that is where we need to be now. So I think that was an incredibly smart reaction to the machine that started to dominate the world, and nature was brought back, dragged back into the design expression through those kind of natural expressions. But we now are asking for much more than that. We're asking for a complete sort of rethinking of how biology and how our sort of humanity that is connected to this biology and to the Earth's processes get involved in the building and the design process. And I think that's much bigger than what the turn of the century was doing. They were building these wonderful buildings without air conditioning, so they really had to kind of make the buildings breathe. But I don't think that system thinking that needs to be part of our thinking right now was as well developed as this one could be, this stage could be. I think we know much more about biology today, and we'll know much more about it in the next 20 years than ever before as it relates to the building industry and to the design industry.
I completely agree, but I would also say that natural patterning is what people love and can connect to in a way that's very intimate. And so in a way because a lot of the things we're talking about, nanotechnology, materials, and so forth, are probably going to be kind of concealed or mysterious or unknowable, just in some ways how nature is sometimes, flabbergasting and just so awing, but also frustrating and confusing.
Sorry, we tried. We really tried.
And I think buildings are definitely getting that way between control systems and HVAC systems, and which is all exciting. But I think in a sense that patterning is a way to actually draw people and to connect people to that natural element that has a scale to it and has a texture to it, and that people can think and understand in a very visceral way. And I think what you're getting to and what we're getting to within the industries is multi-layered
Yes.
element within nature, where it's not just the surface, it's not just the materials, it's not just the mechanicals. It's sort of all these things are sort of, and the control systems are becoming more naturally sort of attuned to sort of swarm technology and so forth. So it's taken over all the pieces, and we're slowly we start out with tents and animal skins creating, our habitation thousands of years ago, and we sort of slowly moved to stone, and then we've now moved to concrete and steel and glass, and now we're slowly trying to figure out a way to get, in some ways, back to these sort of smarter materials that are more natural and more tuned and more visceral in a way that glass is not.
I'd also like to add too, it's been very interesting to work with architects because there is this idea that form, in order for something to be biomimetic, it has to look like an organism. And so when we put forth this idea of performance as being biomimicry, the building might look exactly the same, but the way that it responds and behaves and interacts with its environment is integrated in such a way that it's performing ecosystem services and participating in that environment. So it's the physical form of it's kind of irrelevant in some ways if you can get down to the core performance of it. It kind of takes this whole other step further and changes the criteria for that. And I think it can also be confusing. A lot of times when I work with groups, when I work with design teams, they want that visual component. And the biggest successes that we've had is when something comes out of the charrette process where they have that visual component. And then everybody can kind of point to it as the model, okay, we understand what we're supposed to be getting out of this process now. And it's a little bit fuzzier, I think, unless you really spend time trying to apply life's principles, for instance. That can come out in a number of different ways. One instance that came up, we were working on a master planning effort for a new city for 2 million people in India. And the infrastructure engineers had anticipated having one centralized wastewater treatment system. And so according to life's principles, the way to have a resilient system is to be redundant, to be distributed, and to be decentralized and diverse. So rather than having this one centralized system, I said, well, maybe we should be looking at having multiple systems in different locations with varied technologies. Because then we know if one component fails or one part of that system fails, we have this diversity to back ourselves up. And so what came out of that then was a different design based on that fundamental understanding of what life is, but you can't point to that and say that's clearly biomimicry. So it's a different approach.
So
More questions?
one more. I just want to follow up and then your question. So I forgot. Go ahead.
My bad. I know you'll think of it though.
Hi. My question has to do with the sort of the deterministic quality of architecture. I feel like the practice has become very driven by standards, dimensionally, functionally. We expect our buildings to be very deterministic in terms of pieces fitting together and operating in a very specific way. Maintaining the temperature between two fairly constrained set points, for instance. And it seems like the nature is not generally very deterministic. I mean, it's mutable. It has controls, but they aren't as necessarily always as strict as our culture seems to be requiring lately. And so I guess my question is there a way you believe, given the biomimicry and to develop technologies that will meet those standards, or are we in fact going to have to change our standards to be a bit more natural and not quite so strict? And how do we get there?
I think you have to change.
Well, I just say that nature actually sometimes has very rigid or very narrow temperature and humidity demands. If you look at a termite mound, it actually keeps a very narrow temperature and humidity level inside at all times, and they're always working to sort of open and close ventilation openings to keep it that way. And certain bacteria in the soil actually will die if the soil warms up too much. So if you think about geothermal, if you dump too much heat at certain levels, you can actually kill off sort of whole ecosystems of bacteria that we don't even know exist, but we know they're there. I mean, that's part of the challenge. We still are finding so many organisms. So I would just first say that nature actually has sometimes has very narrow bands of habit, of sort of flourishing. If you look at around different cultures, some cultures are much more flexible with sort of the way we live and what's suitable. I mean, if you just go to Europe, thermal comfort is a much broader topic than the United States.
Yeah, we just throw on the air conditioner.
Yeah, this is the land where the pursuit of happiness is part of the Constitution, which really makes me happy. I think this is the most beautiful
But
thing.
isn't
And it's the pursuit of comfort. Everything is pursued as a European. It's like my happiness is different than your happiness, and I don't care about yours. And that brought us into real bad situations all the time. And I think this is where it's this singular thing that this is the perfection that we try to achieve, and the perfection that we try to achieve with our standards, that sometimes, at least, I don't think it's bad, and it doesn't conflict with biology or anything. I totally agree with you, Chris. But what it really is difficult to deal with is with innovation. Because innovation are measured to a near perfection standard that really puts you at an incredible disadvantage, even so you're so right about it, but you can't achieve that. And I wish it could be sometimes, and maybe that would be for all the people who are in politics, to open venues legally for us to be more experimental. But be clear to our clients about that, be clear to society about that that's not the new standard, that is just like we're trying to work outside of our standard just to move forward. It's kind of like we need to fail, like nature needs to fail. You know, failure is really how you learn it. I see that with my kid. You need to get burned before you know that it's hot.
I would also kind of like to go into a little bit of one of those operating conditions of the Earth. So if you can imagine, one of the operating conditions of the Earth is that the Earth is in a state of dynamic non-equilibrium. So if you can imagine that all of the abiotic factors on the planet, the climate, temperature, the weather, the movement of nutrients, they're a bowl, okay, just like a regular old mixing bowl. And that bowl is always shifting and changing, okay? And life, and I mean broadly speaking, all of the 30 to 100 million species who live on the planet fit in here and are sustainable because as that bowl shifts and those conditions change, it settles down to the point of least inertia, or the place where it requires the least amount of energy to hold position, right, sort of at the bottom of the bowl. But humans, on the other hand, we tend to, so they're round, right? So they're round and they settle down to the bottom of the bowl. Humans tend to build square things, and then we put all of our energy into holding that bowl still. Okay, so think of the very idea of climate control in a building, right? So we're separating ourselves from nature, as we kind of discussed earlier. One of the ways we do that is by controlling the climate around us. And then when people have a hard time understanding what climate change is all about, right? We're constantly putting all of this energy into controlling the climate around us. So it's no wonder why we have this immense separation, right? Because we're not round, we're not responding to those environmental conditions. We're just putting all of our energy into holding the conditions the way they are, or the way we want them, rather.
Yeah, so it's this huge cultural shift that needs to start happening with this new understanding. I remembered what I was going to ask you. But on the distributed energy system that you described, which is really interesting, which says that you're doing things differently. And I'd like to get to the cost of these things, because cost always stops any kind of development or any kind of change. So how, in your work, how does that cost figure into that? Because if you're building 5 systems instead of one humongous one, is it how is the cost figured?
This is a tough question for me to answer, personally, because I'm not an engineer.
Okay.
And we're usually at the front end of these design sessions. And of course, it takes how long to build a new city, right? So it's always a difficult question for me to answer. But the way that we approach these questions is not the cost to the developer, it's the cost over the life cycle, right? And we always try to bring our clients into a place where they understand that life cycle of the building, the life cycle of the maintenance, and the cost that it might be if there's some sort of breakdown in the system. What does that mean for the manufacturers who are relying on that, and lawsuits and all that kind of stuff? You know, all the embedded costs that potentially exist. And also, we focus on ecosystem services and the things that we aren't paying for because ecosystems are providing those services for us. So we try to look at sort of that triple bottom line approach to costing things out. And I don't know if you want to.
Yeah, I think, Chris, I need to hear you say something.
So we've worked on a couple of projects where we looked at infrastructure, and we are also sort of distributed, multi-resilient sort of proposals. And what we found is oftentimes it actually can be cheaper because it can be staged, and with the development, like in the case of a 2 million person city, you have, say, 20 wastewater treatment facilities instead of 3. Well, you can actually, you have 12 stages you can actually add, and so you can defer that initial cost to some later time, and you can use revenue from one of those earlier phases to pay for that, and so you have less debt to carry, which every developer wants to hear. And then also, we talk a lot about sort of the operational costs with our clients. So you build this water system for your resort, and how much energy is going to use? No one knows. We're at the design table. We're talking about a very well-known standard system that almost all resorts, sort of outside major areas and sort of in the Central America, the Caribbean islands, uses. And we've budgeted this much money. We're like, well, the system we're talking about uses 10% of the energy the system you're talking about, and in this country, energy's 25 cents a kilowatt. And and the hotelier's eyes brighten up and say, wait a second, that's our profit margin you're talking about. So, I think we do have to, it isn't always a cheaper first cost, but usually when you talk about first cost and operating costs, you can usually find a natural system or a bioutilization system that's actually more resilient and more cost effective. It just is different. And that tends to be the hardest thing, is you get the guys on the ground who have been told to build it in 3 months, that then they become the next, so that's the next level. You've got the CEO excited, you've got the operator excited, now you go to the guy who has to build it and you say, listen, it's not that hard. There's one 200 miles away that's operated, you can go kick the tires on. And then they kind of get excited. They're like, okay, let me go check it out. And then they come back and say, okay, it's not as complex as I thought it was going to be. So that's sort of the process we use, sort of, get all those barriers. And sometimes there's a regulatory barrier you have to also deal with. And usually you need an existing system that you can take them to, or an existing code official who's approved one, and let them talk through how they saw it and how they were able to approve it.
So this life cycle costing is becoming more part of the conversation in buildings, or are we still dreaming? I think, it's really interesting to me that we've been talking about this for quite a while in terms of product development, buildings, how long do they last, how do they function, so the cost isn't that first cost, it's a much more sophisticated idea of economics than we're used to. So in your experience, is that becoming the lingua franca now? Is it becoming something?
In our experience, first costs and operating costs everyone talks about that now. 8 years ago, it was really first costs. And you do have different development models, which can be challenging because they really are first cost driven only. Life cycle cost of embodied energy, it's within the conversation, but a lot of times we don't have all the data we need to really give good answers. And I think that we're still learning about embodied energy of products, and we still need more tools with our manufacturers to communicate these issues, just like describing what's actually in products chemically and what those chemicals do and how they off-gas inside our environments is a similar issue that is much easier to have a conversation on, but we still have a lot of questions that we're learning from.
But these words do come up.
Oh, yes.
And they are part of the development community, and they are beginning to gain some traction. So we're beginning to understand something. And as a follow-up on that, for years, the one thing that I heard from architects when we talked about some innovative work or something new with the building envelope or anything new is the code. I can't do it because of the code. And the codes are changing in a very interesting way. Cities have policies, green policies now that are rewriting the codes. So the two architects, your experience in the codes, how they support this kind of nature-informed innovation? Do you feel that? Do you see that? Are you beginning to notice that? And then Chris.
I'm not sure if it actively promotes green building, but what I see is that codes get more basic, and basic codes, like simpler codes that are not so specific, allow for more interpretation, and that is the way you do that, I think.
Well, that's very hopeful.
It's just like this week I had to deal with like ADA issues, and I'm glad that it got like less specific and more about principles, which is really what we're trying to learn from you. And be not specific about it, understand the principle, and then apply the principle to whatever you're doing right now, but not like you're not teaching us a solution. And if the code doesn't teach us a solution, but there are the limits. ASHRAE codes about like, which we all know as architects, we love those. There's a mechanical code that set the exact temperatures in buildings. And if you now try to, in South Carolina, we tried to have an auditorium that was open, that was cooled with a cool water wall. Well, not every part of the building can now conform to those ASHRAE things. But thanks God there is a little limit that is like the natural ventilation allows you a little more a variation in it. And when you find those, then you can get there. And I think hopefully all those codes will acknowledge and will just pull back to like a basic principle rather than the description of a solution. And then we can definitely work within those codes, and codes are necessary and good guidelines too. And I think standards too. I'm not anti-standard. It's just like sometimes yes.
Well, yeah. Sometimes they're not keeping up, but I think you guys build a lot of places.
Yeah, I have two anecdotes that I think are very promising. In New York, 150 professionals donated their time for what was called the Green Codes Task Force last year. And it's really looking at removing impediments and as well as raising the standard of performance standards for the city. And they were all recommendations that are now going through the legal process. And so far, 11 of the 117 have been adopted by the city. And it was completely outside of the standard code revision updating process. And it was, the sort of leading professionals in the city who are working on, green buildings and sort of working around the world, for people from HOK and from SOM and some of the major engineering firms participated in this. And it was really about, let's, make building more efficient. Let's make buildings more efficient. Let's make the process, not just building, but even the process and some of the conflicts between the health code and the building code and how we deal with water. And it's really interesting because I think there's a unique moment, especially in city government in particular, that these cities are just clamoring and so excited to do different things and to remove some of the impediments we've had for for many years. Another example is in Portland. A colleague, Clark Brockman, was working on an eco-district project, and they started realizing there were all these different code issues that were really hindrances to moving forward with this district system ideas. And so they got all these officials in the same room and just talked through them and said, we understand, this part of your fire code, but we're trying to do these three things, and this piece of the code makes it impossible for us to achieve our goal of sort of zero water and a couple other issues. And they worked through with the fire marshals, and we did this in New York on cogeneration and plants inside buildings. And there's this openness to talk about, instead of just saying, this is the code, you have to comply, here's an inspector, you didn't comply, you're getting fined, or your building is being stopped construction, there's a more of an interest of, what are you really trying to achieve? And we recognize our codes are old. I mean, this New York City's code hadn't been updated since the 60s, when it was updated in just actually a couple years ago to an international code. So it's that sort of problem we have in general that we're really working on now in the cities. I have great respect for everyone who works in city agencies because they're doing amazing work right now, and it's really exciting to see.
So it feels like we're in the middle of a revolution.
I hope so.
If I might add to that, Jason McClellan works with the Cascadia, or he's the founder, I think, of the Cascadia Green Building chapter. And He's doing something called the Living Building Challenge. For those of you who aren't familiar with it, basically the premise behind the challenge is, what if a building performed like a flower? And so we've been working with them to help them shape their guidelines for the design challenge and these sorts of things. And his philosophy is change the building code. Try to figure out what it takes to change the code itself to meet the performance standards that you want. And I guess I think it's along those same lines. And people, it sounds like people are responding. You know, so.
It'll be slow. It'll be challenging at different scales of buildings and communities. But we wrote them. You know, a human being wrote them once. We can rewrite them now.
Right.
So why not?
But you know, what's really interesting to me, and I think we have to wrap up here, is that on a local level, there's so many U.S. mayors who are really green friendly, and they understand this really well. They understand their resource problem, they understand their water problem, their energy issues, they understand the health issues. They are right on those front lines, and they're the ones who get attacked immediately because everybody's at them all the time. You have access to the mayor, you don't have access to your senator or your whoever it is that is on a larger level. So I think the U.S. mayors right now are very exciting to watch because their cities, small towns, are beginning to shift into this sort of more nature-inspired, more green, more biologically connected way of being. So I think it's a beginning of something very good here.
Why don't we take one last question? And I can take one last question, and then I'll give you a heads up. We'll have some closing thoughts too, so something to think about.
So first I wanted to thank the panel for coming out tonight. I work for the district here, helping to manage a program that's replacing derelict public housing with mixed-use, mixed-income projects. And Chris was nice enough when he got here today to spend some time with us. One of the biggest challenges that we face now is getting developers to stop thinking about LEED and green communities as the ceiling. It's a familiar set of models, principles. There's scale around the country, and it's something that they understand. So now we're beginning conversations about thinking of the projects that we're developing in the direction that you're moving in, and getting resistance or outright rejection of some of our recommendations. So I wanted to know from the panel if you think we're at a point where we've scaled up in terms of projects, materials, and systems that we can point to the way we did just a few years ago to say, well, look, there's a viable green community over in Maryland that you should go take a look at, kick the tires, and see that it's not that exotic. So I wonder if the panel can talk about systems, developments, projects, and materials that are at a scale that we can direct developers to, that we can learn from as we try to apply some of these models to the next generation of projects we're developing here.
The first thing that comes to mind for me is, it's called the Landscape Performance Series, and it's a series of case studies that was just released at Greenbuild last year, done by the American Association of Landscape.
ASLA.
Yes, thank you.
Yes.
I couldn't remember the acronym, but I could remember the whole name. I don't know. Anyhow, so we consulted with them a little bit on how that was going to be coming together, and we had an intern. We shared an intern that developed their content and worked in our offices. So they are looking at performance, actually, of landscape designs and how to really quantify that. I think the case studies are out there, but they haven't been, LEED case studies are well organized. And so the case studies for biological performance, ecological performance are more scattered across the country, but they're there. It's just a matter of bringing them together in one sort of format that is really accessible. I would start there, though. Do you guys have anything to add?
I mean, I would add, a thing about passive houses are, very sort of easy to understand. I think, the idea of having a zero energy home would scare a developer, but actually when you walk through a passive house, which is very low energy consumption, it actually isn't that big a deal. I mean, it's all sort of noble technologies. And actually there was an event last night in New York where the NREL's new office building out in Golden, Colorado, which is a 220,000 square foot net zero energy building, is operation, and it's meeting its goals. There was a presentation last night in New York, and actually all the strategies they used were really straightforward, and it was built at market rate for the Denver, Colorado region, and it sort of really shows that it's possible. Now, it might not be the most beautiful building in the world, but it's also it's not bad, but it's day-lit, it's beautiful office spaces, and it's a kind of data center inside the building. So it's an amazing achievement, and it shows that it was a design build with a contractor, and it's really an impressive project in the sense that it achieved at a market rate with sort of a great client, definitely, that was really understood, but government contracting regulations, I mean, talk about barriers, they had a great climate, but I think they're out there. I mean, Dockside Green is a great community in Vancouver. There are some really, amazing projects out there. I think the challenge is they each sort of do one or two things really well, and now we want to see 5 and 6 things done really well in one development, one community. And I think that's where we're going, is trying to take each of the major successes of each of them and pull them into one project. And you can see that from Portland to DC to New York to Boston, everyone is trying to figure out how to do that. And so soon.
I would ask each of you actually to, and I'll follow up on this, but if you can email me some of those examples that you gave, we'll post that up on our website along with the video. Sure. So that'd be great. Any closing thoughts too for the panel as we wrap up?
I think that we really need to rethink design education and put biology at the center of it.
I agree.
I mean, I'm not. This is not. I'm not kidding here, because I really do think that without understanding those principles, I don't know how a designer will incorporate some of those systems, and it's not. Learning to design Art Nouveau, beautiful, elongated flowers, but it's about learning nature systems and behaviors and economies and interconnectedness. And that is not going to happen in architecture fully developed until we have architects who understand that those systems are at the foundation of building.
I think that more and more biologists, more and more scientists are realizing that we have a cultural epidemic of scientific illiteracy. And more scientists are stepping forward and really trying to communicate. And I had one of my roommates in college is a biblical literalist. And she said to me that I was the first nice biologist that she had ever met. I was like, whoa, okay, we have a lot to work on as a community. So I think that it's a matter of this literacy, it's a two-way street, right? Like the thing that I'm always struck by when I work with designers is the types of questions that you ask and the way that your worldview is shaped by the things that you have studied and the things that you create. In the same way, my worldview was shaped by my education. And so there's this sweet spot that exists when our questions come together that we could not have asked on our own. And I think that communication, that cross-discipline communication in a way that's really challenging, and it's not, we're not afraid of sort of the confrontation that comes in that and the discomfort that comes in bridging that gap. I think we need to really explore that as a society.
Yeah, I think that goes into when we talked about the singularity of our disciplines, which came to the singularity of our sewer system. Everything appears to be the same thing. And it would be nice to change, and I think it's already happening, that if I look at MIT, that architectural education really is there is, the way I brought up, there was the insight in architects, they can talk a lingo that, like biologists can talk a lingo that nobody else will understand. And so we're past that. That's not cool anymore. I'm trying to communicate with somebody who doesn't speak my language. And so to get to the outside disciplines. And it's a challenge for architectural education to at one point also educate the core values, the things that architects really do and that differentiates them from a biologist, no? Because you need to master those. At the same time, you need to be able to just go everywhere and people come from all disciplines to you. So it's interdisciplinary. But the question really is, in order to be like biology, which you would use an enzyme or something, and then just it would explode, you know, it's a kind of something to make this a rapid thing. How can we do this in architectural practice? How can we change architectural practices to incorporate other disciplines and not being afraid that being told from a electronic engineer that this is a great idea, but you know you're missing the major point of it, and this is how in his view things should happen, and start a conversation rather than just like not, and also be able to connect to those disciplines. You know, I wish they would be all you know, arts, humanities, and everybody would sit up here and not only architects. I think this is a great beginning, but there should be an electronic engineer, there should be a material scientist, there should be somebody in theater. Yeah, I mean, the way I went to SciArc, I know I had one of my crits that was a magician, but only at SciArc, because SciArc is kind of like the goofiness of all architecture schools, would invite a magician, which makes all sense, because architecture is about an image, an atmosphere. It's to somewhat, we're trying to do an illusion of something. You know, we're trying to create something that is exactly what a magician does. You can learn very much from a magician, even though that's not a science. You know? So I think that's what we need to instill in the practice of architecture, not to be afraid to learn from a magician or get criticized by a magician, and not just brush it away and say it's like, well, that guy doesn't really understand architecture.
Well, and there's a system in place. I mean, you can't, your buildings won't stand up without your structural engineer. So you know how to collaborate. You know how to work, and or at least I assume you know how to work collaboratively. And you have, if you want a really great interior, you're going to consult with a really great interior designer or architect, because as a form giver, you're probably not equipped to do that interior. So I mean, and if you want some special materials that you haven't thought about, you go to the materials expert. So you already have it in place.
But it's moving to a different level. I mean, I agree. We, as a practice, there's always been these. Well, for the last 100 years, we've had these subdisciplines, but way too often we're handing our design off to a structural engineer or a mechanical engineer saying, fit in your systems. You've got 18 inches. Good luck. And I need it tomorrow. And that's how too many architects work, and it doesn't work any longer. And we can see it just, the business world is now saying, we don't even accept that model any longer. With our consulting practice, I'd say a lot of our practice is around breaking down these silos and bringing in people that wouldn't normally be at the design table, whether it's a botanist, a biologist, an archaeologist, a lighting designer that has a very specific knowledge base that is unique need for that project. And once the team starts to hear these things, that's when the amazing things really start to happen. The fun really starts when everyone sort of steps back, and allows themselves to hear the other people's expertise, whether it's the project structural engineer or it's a specialist in biology. Then they say, wait a second, oh wait, if that's the problem, then can't we do it this way? And then those architectural juices get going because they're being fed new information, which many architects are sort of information freaks and just absorb information constantly to sort of inform new design, inform making. And I think that's catching on. And I think, even contractually, we're starting to see a transformation in the way we're thinking. And even on the construction side, you're starting to see at least an interest in a more integrated approach so that there isn't this sort of design, construct, operate. And even, operations now is even becoming more integrated in the design phase where the guys operating the building are actually at the table saying, that doesn't work. I can't run this building if you do that. Like, it will break and we will replace it, so your design will not work. And owners really listen to that kind of stuff.
So at Cook and Fox, when you start a project, that day when Rick Cook brings in this project and say, hey guys, we have to construct a 20 million square foot thing. and so do you bring in all your consultants when you start brainstorming? And is like if you need a biologist,
Yep.
will she be called? And so, I mean, is that a matter of fact right now at Cook and Fox?
Yeah, deep historical research on the project. We work regionally between Boston and Washington, so we keep a very narrow geographic range so that we really can understand where we're building. Cities are an amazing, complex organisms. So we choose to work really just in that region. And we bring in, we do what we call an environmental opportunity charrette, where we really try to think out what's the possibilities for this project. How can we do, what's the best thing for this project? It's not, is it LEED, this or that, the other thing, or is it a living building? And maybe we will use one of those standard tools to help us understand how far we've gotten along on a path. But it's really about understanding what the client's needs, the community's larger needs, and then how those things come together in that particular site with the technology we have today.
And with that, I think we're going to have to wrap up, but I'd like to thank all of our panelists and Susan for moderating. And to thank all of you for making it through the snowstorm. Please travel home safe, and we hope to see you again soon. Thanks a lot.